In this video, we will solve a question on how to find out the minimum and maximum point of a given function. The question is given y is equal to x cube minus 12x square plus 36x plus 8. Find the point is where the function reaches minimum and maximum. Okay, so we are being given y is equal to x cube minus 12x square plus 36x plus 8. This is our given function. Okay, so if I draw a simple graph, okay, so if I can draw it, so we have x on the horizontal axis, y on the vertical axis. So drawing a rough graph, so let me try to draw the graph. Okay, this is our y function. Okay, we need to find out the points where this function reaches maximum and minimum. Okay, so first order condition, that is first order condition for optimum requires that we take the slope of this function and set it equal to 0 to find out the point where slope is equal to 0. Okay, so that means dy upon dx. Okay, so first order condition is simply we find out the point where slope is equal to 0, so that means dy upon dx should be equal to 0. Okay, this condition satisfies the condition where slope of the function is equal to 0, which dy upon dx is derivative of this function with respect to x. So we get 3x square minus 2 into 12 is 24x plus 36, and derivative of constant is 0, and we set it equal to 0. Okay, so solving this will give us the point where the slope of the function is equal to 0. Now since 3 is divisible by 3, 24 is divisible by 3, 36 is divisible by 3, so let us divide both sides by 3. So we will get x square minus 8x plus 12 is equal to 0. So this is our quadratic function, and we can solve it using splitting middle term. That means x square, so in place of minus 8x can we write minus 6x minus 2x, and in place of 12 can we write minus 6 times minus 2. So splitting middle term using quadratic formula. So let us take x common from the first two terms. So we are left with x minus 6, and let's take minus 2 common from the last two terms. We are left with x minus 6, and we set it equal to 0. This also equal to 0. Now how do I got this minus 8x equal to minus 6x plus minus 2? It is very simple. Given this quadratic function in standard form, we should get sum of the two numbers should be equal to the coefficient of the middle term, which is minus 8, and the product of the same two numbers should be equal to the constant term, which is equal to 12. Okay, here you can see when we write here minus 6 and minus 2, it satisfies minus 6 and minus 2 is minus 8, and minus 6 times minus 2 is equal to minus into minus is plus, so we get 6 2s are 12. That's how we got minus 6x minus 2, that is this minus 6 and minus 2 is equal to minus 8x, plus in place of this we write minus 6 times minus 2, which is plus 11, sorry, plus 12. Okay, having said that, let us take x minus 6 common. We are left with x minus 2, and we set it equal to 0, which implies here either x minus 6 is equal to 0 or x minus 2 is equal to 0. X minus 6 is equal to 0 means x is equal to 6. X minus 2 is equal to 0 means x is equal to 2. So we got two critical points where the function has slope equaling 0. Okay, so this is first order condition, that the slope of the function should be equal to 0. Now second order condition is that the point where slope is equal to 0, at that point the slope should be, that is d square y upon dx square, which should be less than 0, or slope should be decreasing, less than 0, negative slope. Okay, for it is a condition for maximum, and for d square y upon dx square, when we evaluate it at the critical points, it should be greater than 0 for minimum. Okay, now let us take it one by one. So first we need to find our second order derivative d square y upon dx square. Okay, and we evaluate it at critical points. So this is the first derivative dy upon dx. Now the derivative of first derivative gives us second derivative. So again differentiating this with respect to x. Derivative of x square is 2x, so 2 into 3 is 6x, 6x minus derivative of x in the second term is 1, so we are left with 24. Now we evaluate it at critical point. So d square y upon dx square, when we evaluate it at x is equal to 6, first x is equal to 6, so plug the value. So we have 6, in place of x we write 6 again, minus 24, so it is 36 minus 24, which is equal to 12, which is greater than 0. So this point x is equal to 6 satisfies the condition for minimum. Okay, because we got d square y upon dx square greater than 0, and it satisfies the condition for minimum, relative minimum. So at this point we will have minimum value of the function. Now let us evaluate at x is equal to 2. So d square y upon dx square, then we evaluate it at x is equal to 2, will be equal to, so 6 times the value of x is 2, minus 24, so it is 12 minus 24, which is minus 12, so which is less than 0. So this point satisfies the condition for, since it is less than 0, this very condition, it satisfies the condition for maximum. So at this point the function will have maximum when x is equal to 2. Okay, so first order condition gives us the slope is equal to 0, so this is FOC, that is slope is equal to 0. Second order condition tells us the second derivative should be less than 0, that is d square y upon dx square should be less than 0 for minimum, for maximum. And at this point when we evaluated d square y upon dx square, it should be greater than 0 for minimum. Okay, so when slope is equal to 0, that means dy upon dx is equal to 0 at this point, and at this point also slope is equal to 0, dy upon dx is equal to 0. So this condition, so this function reaches its relative minimum at x is equal to 6 and relative maximum at x is equal to 2. I hope I make myself clear in this video and you find out this video helpful. Thank you.